Hey Riley, what's up? I'm so sorry. The Zoom didn't work out. The hour wasn't working out for you. We do miss you a lot. Hopefully you get out of quarantine and come and join us in the class. We hope to see you very, very soon. But I actually made this video especially for you. So what I'm gonna do is that I am actually going to go through the slides we did for today. Go through a couple of problems we all activities we also did for today, and hopefully it will bring up to speed to what you basically need tomorrow. Okay, so what I'm going to do is I'm going to post this on YouTube. I'll send a link. I'll basically send you an email as well once it's all done and posted, and we'll basically move on from there. Okay, how about that? Sounds good. Sounds good. Okay. Right now, let's look at what we're basically going to be doing today. So we essentially looking, oops, let me not use presenter view. We're looking at chapter 8, okay? So chapter 8, we basically focusing on trend lines and regression analysis. Hold on, let me just make sure this is actually recording. Oh yeah, it's not recording the whole screen, so that's the most important thing. Sorry, just give me a sec. Let me just try and figure stuff out. Right. So chapter 8, we will basically looking at trend lines and regression analysis. Now, when we say trend lines and regression analysis, basically we're trying to predict maybe sales, or we're trying to predict certain things, right? Now, so far last week, we've been looking at the fact that, things have generally been described in data. But right now, we're trying to be a bit more predictive. So this is where we look at predictive analysis, okay? And regression analysis is basically generally used in trying to predict a model or in trying to predict something, okay? Right, so that is what we're going to be looking at, okay? We're going to be using trend lines, which I'll teach you how to use, and regression analysis to basically make a prediction. Now, if you're going to be a financial manager or an investment analyst someday, or a portfolio manager someday, you need to basically create a portfolio, right, with a really high return. Now, for you to create a portfolio with a really high return, you need to predict how stocks are basically going to change, or the price of stocks are going to change in the future. If you want to be a good marketing analyst, a good marketing research, you need to predict how sales are basically going to change in the future. Okay, so there's a lot of prediction in businesses. Okay, and that's what we're trying to look at in chapter 8. And basically this week, okay, we'll look at trying to predict different variables or different factors, and eventually also we'll look at how to basically forecast certain things like sales, for instance. Okay, right, so that's what we started with. Again, the class is always thematic. We go through different themes, and today we basically looked at simple and multiple linear regressions. We didn't have the chance to go through everything, right? You actually missed Kahoot today too, so that was that was pretty interesting or sad, I would say, right? So first of all, we use the Excel trend line tool. Okay, I'll show you how to do it to fit models to data. Again, you're trying to fit models to specific data you might probably have to actually sort of derive a relationship from the data. Okay. And then we'll also use Excel functions to basically try and find what we call regression coefficients. And I'll basically explain what regression coefficients essentially generally are. Okay, we'll also use Excel regression tool for both single and multiple linear regressions. Today, we couldn't really do multiple linear regressions. We basically stopped at single linear regressions, okay? But then we learned how to interpret the regression statistics of the Excel regression tool. So people know how to, or the students hopefully know how to basically interpret whatever regression results they get. Okay, now tomorrow and hopefully on Tuesday, and not spewing into Wednesday, we'll learn how to build a good regression model. So what does it take to actually build a decent regression model or a very solid regression model, right? What are some factors that we need to look out for in trying to build a regression model, right? So in doing that, we basically will apply a systematic approach in building good regression models. And I'll explain something really interesting, which has to do with what we call multi-collinearity, okay? Multi-collinearity in regression models, and it has to do with high correlation between different variables or different factors. And that is essentially what we'll look at, okay? And then theme 3, that is also going to be for tomorrow and perhaps Tuesday, okay? We'll look at more advanced regression models, okay? So we look at regression models that basically contain categorical data using what we call dummy variables, and I'll basically explain what those are later on. We'll also learn how to interpret regression models with categorical variables or categorical data, okay? And in some cases, linear relationships don't really work. All right, so we look at models that basically tend to be nonlinear, hence we call them curvilinear because they're sort of curved, okay? And we'll look at how to basically run those regressions to a game. The main theme behind this chapter, Riley, right? And the main theme behind what we're doing this week is trying to make a prediction. If I'm trying to find the market value of a house, for example, basically, how do I predict it? If I'm trying to find sales, how do I predict sales? If I'm trying to predict like stock price, how am I trying to predict it? Okay, that is basically the sort of the gist of what we're basically doing. Okay, now before I actually delve into it, there's a couple of lingo that we need to understand. Okay, and going forward, we're going to be using this lingo, often. So that's lingo you need to know, and lingo I did explain in class that you basically need to take a look at, okay? The first one is what we call categorical data. Now, categorical data is basically data that is sorted into different categories, right? According to certain characteristics, okay? So a good example of categorical data is, let's say, gender. So with gender, you have female, right, or male, for example. Okay. Another example of categorical data is race. Okay. You have different categories. You have white, you have black, you have Hispanic. Okay. Right. Those are examples of categorical data. Let me give you another example. I'm sure you can even think of other examples. You have regions, right? So maybe you have North America, you have South America, maybe you have Asia. Okay, these are categorical data. Now, with categorical data, clearly you can see that they tend to be sort of in text. Okay, you're using it to describe something or using it to describe someone. Okay, that is what we mean by categorical or nominal data. Okay, we usually use categorical and rarely we use nominal. Okay, now we also have what we call ordinal data. Now, ordinal data is basically data that is ranked. So, for example, if I'm having a survey, you rank a survey. You have 1, which is low, and maybe 5, which is high. So for example, you're looking at customer satisfaction, okay, on a ranking or on a scale of 1 to 5. Well, you hear that a lot, at the scale of 1 to 10, right? Rank how satisfied you are with this product, okay? So 1 being low and 5 being high, okay? That is ordinal data, where you basically rank your data according to some specific orders, maybe some specific relationship you're basically looking at, okay? So customer survey is a good example of ordinal data, okay? And then you have what we call interval data. Now, interval data is basically looking at things within certain periods. You know, it's more periodic, okay? So a good example is like temperature. Okay, temperature is a really good example of interval data, right? But when you think of interval, what comes to mind is dates, okay? So a good example is time period or different dates, okay? When you actually have data that is basically sort of dated, essentially it tends to be interval data. Okay, it tends to be interval data, and that is essentially how they look like, or how it basically looks like. Okay, now the final one is what we call a ratio data. Now ratio data is, well, data that is in proportion to another. So it's just generally ratio data is numerical data. Okay, so for example, sales, cost, revenue, profit, all those are ratio data. Okay, like for example, you have maybe 290. Well, that in a way is a ratio. Okay, so $2.90. There is a ratio, but generally numerical data tends to be ratio data. Okay, so these are the kinds of data we basically have. Now, generally, when we're going forward, we're going to be looking at categorical data and ratio data, which is just numerical data, right? So it's either your data is in numbers or is basically specified according to certain categories generally, right? Now, if you're looking at that, your purchase order, right? So let's look at a purchase orders data sheet. Okay, now you don't need to open this data sheet, but suppliers, for example, is categorical data. Okay, you sort of given the names of different types of suppliers. Okay, now you also have another categorical data, which is basically item description. Okay, And then you have your ratio data. Now, clearly, as you can see, the ratio data tends to be the numbers. Okay, so ratio data tends to be the numbers. And then you have your dates, which tends to be the interval data. And then you have your ordinal data, which is basically sort of ranking, you know, when an order was taking place, or when an order to basically took place, or whatever. Okay, so this is the kind of data you have. Now, you don't necessarily need to sort of know this, but it sort of helps you in actually understanding sort of like statistics lingo or statistics language, essentially. Okay, so that is why I'm going through it. Okay, now the first thing we need to do is basically sort of know certain mathematical functions that are essentially used in terms of predictive analytical models. Okay, now the one we're going to be using the most, and the one I want you to worry about, Riley, okay, is essentially the linear models or the linear function. Now, if you remember, this kind of looks like the equation of a line, and I'm sure you probably remember equation of a line from high school. Okay, so you have some variable which is basically y, or some factor which is basically y, and this y is a function of a plus b times x. Okay, now in terms of the logarithmic, the polynomial, which is quadratic, cubic, power, and exponential, we rarely use it. If I was you, I wouldn't really worry about it, but this is what you need to worry about. Okay, remember the a was basically the intercept, and the b was basically the slope as well. Okay, so we're saying that y depends on a, some number a, which generally was the intercept, right? Some number b, and then maybe some variable or some factor x. Okay, these basically sort of explain y, and it's generally a linear relationship. Okay, if every time you have addition, it generally tends to be a linear relationship. Okay, now this is what we're going to be focusing on for the rest of the semester. Right, I don't want you to worry about these ones. Okay, these ones are just there so you sort of look at them and see how essentially they are, but this is what we're going to be focused on. Okay, now every time you have some set of data, you can always find a linear relationship within that data. Okay, and that is what we're trying to look at. Now the linear relationship helps us to predict how some factor will basically change, or how some variable will basically change, right? Now, if I know how A changes, if I know how B changes, and if I know how X changes, I can sort of make an assertion as to how Y will change as well, okay? So that is why we need to know that linear relationship. Now, to actually find that linear relationship in Excel is relatively simple. We need to use what we call the Trendline tool, okay? Right, and the Trendline tool basically helps you determine sort of like a functional relationship between two data sets or two sets of data. Okay, so it helps you find a functional relationship between two sets of data. Okay, and I'm going to show you how to use the Trendline tool. So I want you to download the price sales data. You need to go to my Wurzburg, you need to go to the course page and under module 5. Okay, so this is under module 5. Right, basically download the data set, and we'll work from there. We'll basically look for a trend line. Okay, now to actually find a trend line, the first thing you need to do is basically draw a scatter plot. Okay, so the data you have sales and price, and I'll actually show you this. Okay, but you need to draw a scatter plot between sales and price. So let me just exit from here. This is going to be a bit informal. Okay, and let me just open the price sales data. Okay, so we have this. So I'm going to draw a scatter plot. I'm going to select my data. I'm going to go to insert, draw a scatter, and basically I have it. Okay, I actually like the black background generally. Okay, right, so first of all, let's just take a look at this data. Right, clearly you can see that there's a negative relationship between price and sales. Okay, so we have price on our x-axis. As price increases, okay, sales basically decreases, which actually makes sense. As things become more expensive, you actually have people buying less of it. Okay, so as price increases, sales generally decreases. Okay, but I want to have a sort of linear relationship with this. I want to be able to predict sales. Suppose if I decide to set my price to, let's say, $400, what is going to happen to my sales? Well, based on the data I have, I can sort of create a relationship that basically shows this, okay? All I have to do is go to Add Chart Element, go to Trend Line, go to more Trend Line options, make sure that you actually select Linear, and then from there, select Display Equation on Chart, okay? When you select Display Equation on Chart, an equation appears here for you, okay? And this is a linear relationship, okay? This relationship is basically trying to explain sales. Now you have Y over here. This Y basically corresponds to sales because sales is on the Y axis. And this X over here corresponds to price, okay? Because price is basically on the X axis, okay? Right, so we have a linear relationship over here that tries to explain how sales is related to essentially the price, okay? So we have this relationship over here. Now, how did we get this relationship? We simply use the trend line tool, okay? And that is what we did, okay? So I'm just gonna exit this and let us go back to our slides, right? So we drew a scatter plot between sales and price. We went to our chart element. We chose trend line. We went to display equation, right? And for now, don't worry about display R squared. We'll go to it later, okay? Right, so we have a linear function, okay? So we created a linear function, right? But before I actually sort of delve and explain what that linear function basically means, let's just take a look at a linear function, okay? Whenever you have an equation that looks like this, y equals a plus bx, remember this is an equation of a line. Okay. The a here, if you remember the equation of a line, is your intercept. It's also known as a constant, okay? Also known as the intercept. You can use both words for it, okay? So you have a, which is basically your constant or the intercept. You have b, right, which is the coefficient or also known as the slope, okay? Now you have x. X is what we call an independent variable, right? So for example, I'm trying to predict sales, but what am I using to predict sales? I'm using price to predict sales, okay? So whatever you're using to predict something else or whatever factor that affects something else is known as the independent variable, okay? So in this case, my price is the independent variable and y is the dependent variable. In this case, what I'm trying to predict is sales. Okay, so sales is the dependent variable. Sales depends on basically how I change my price, okay? So that is something you need to know, okay? So suppose I want to predict sales, hence sales would be my y and price would be my x, okay? If I want to predict sales, I need to find a linear relationship between sales and price, okay? So I can write this as sales equals some constant a plus the coefficient, right, times maybe some relationship called price, or in this case, basically the independent variable called price, okay? So let's just look at this equation. If I assume that my price is $10 and my constant is basically $8 and my coefficient is negative 0.5, what is essentially going to be my sales, okay? If I have these figures over here, I can sort of predict what my sales is essentially going to be. All I have to do is just plug these numbers back into this equation. I'll call it equation 1, and I should be able to have my sales, and my sales is basically $3, okay? So given this, I basically have my sales as $3. If my price is $10, if that constant is basically $8 and B is negative 0.5, my sales is going to be $3, okay? Now, I know this. Assume I want to basically change my price, okay? So assuming I want to increase price by $1, how much will my sales change? Suppose I'm actually a marketing analyst, right? Initially, our price was $10 and we're making sales of $3. Now, I have this model over here and I want to change my price from $10 to $11. How is my sales basically going to change, right? Now, all I have to do is basically plug it back in. So the new price is $11, okay? And assuming that A and B are the same, okay, right? My new sales is going to be $2.50. Now, clearly, you can actually see that my sales has decreased. Now, why has it decreased? Well, there's a negative number over here. Okay, there's a negative sign over there. So clearly, my sales has decreased. Now, in that sense, okay, we basically know that in this case, if we increase price by $1, our sales is basically going to decrease to some amount, okay? In this case, it basically decreased, okay? Now, how much does our sales decrease by? Our sales decreased by 50 cents. And clearly, you can see that the decrease is the same amount as B. Now, this tells us something. Every time you have a linear equation, let's say y equals a plus bx. If x increases by 1 unit, y is going to change by b units. It's always going to be that case. Every time you have a linear relationship like that. If x changes by 1 unit, y is going to change by b units. Okay, so in this case, when price changed by $1, right, sales decreased. Well, why do we have a decrease? Because we have a negative sign over here. Sales decreased by basically 50 cents from $3 to $2.50. Right? So every time you have a linear equation, if the x variable increases by 1 unit, the y variable changes by b units. And this rule is always the same. Okay, this rule is always going to be the same. Okay, so going back to our sales equation, we have sales equals A minus 0.5 times price. If price increases by $1, then sales will decrease by 85 cents. Basically, that is what it means. Okay. At the same time, if price increases by $10, then sales will decrease by 10 times 0.85, which is basically $8.50. Okay. Now, if x equals 0, then this equation becomes y equals a plus 0 times x, and then y equals a. So if we set no price, in this case, if we set no price, okay, our sales will just equal a. If a has a number, that is what our sales is basically going to equals. Okay. Right, now let's go back to our demand function. Basically, let's go to our linear function, okay? We're able to basically predict sales. Now, we had this sort of linear equation. Okay, let me just go back. We had this linear equation for our sales. Okay, now it means that if price increases by $1, our sales will decrease by $9.50. So sales will decrease by $9.50. So every time we increase our price by $1, our sales will decrease by $9.50. Basically, that's what the model is trying to tell us, okay? Now, if price is 0, it means that our sales will basically be 20,512. Now, our price will never be 0. And if you actually have price of 0, basically you're not selling anything anyway, right? So it doesn't really make sense, but we'll actually explain that later, okay? But that is what our equation basically sort of means. Now, how are we really sure this equation is really true? Now, in business, you're always thinking about the fine margins, okay? You always think about the margins. If I increase price by $1, how do I know that sales won't decrease by $20? How do we know that it's going to decrease by $9.50? Well, you can actually test it. Now, you test it by using what we call the R-squared. Now, R-squared is a measure of the fit of the data, okay? So the R-squared basically tells us how sure we are as to how that data is basically accurate, okay? So generally the R-squared is always going to be between a value of 0 and 1. you generally want your R squared to be a value of 1. Okay, generally you want your R squared to be a value of 1, and a value of 1 basically indicates a perfect fit, and that is what you want your R squared to be. Okay, so most R squared won't give you a value of 1 because that is too perfect. So generally, if your R squared is roughly around, so let me use my pen, if it's 0.8, 0.9, then you're basically happy. Okay, so generally you're happy over there if your R squared is 0.8 or 0.9. Now, you can actually find your R squared, okay, using the trend line tool, and I'll actually show you how to do it. Okay, so the larger the value the R squared, the better things generally are. Okay, the better the fit is. Okay, now how do you find R squared? Now let's go back. Okay, so I'm just gonna flip flop a little bit. Now, once you select your data, or once you select your chart, sorry, right, you can go to our chart element, you go to trend line, more trend line options, and you select display R squared value on chart. Once you do that, you actually see your R squared, okay? And you have your R squared telling us how good price is able to predict sales essentially, okay? How good price is able to predict sales essentially, okay? And in this case, we have our R squared being 0.8, so that is generally good. That is something we want to see, and that is generally good. Okay, so in our case, our R squared is essentially 0.8. Okay, it's essentially 0.8. Okay. Now, I also had some worksheet problems. So you can actually go to module 5 and download the worksheet problem and basically try and solve it. Now, I don't think I'll probably have too much time to basically go through the worksheet, but I do implore you to work through it. And if you have any questions about it, please see me tomorrow, or you can send me an email. Sorry, you probably won't see me, but you can send me an email. Sorry, totally forgot you're still on quarantine, but you can just send me an email and I'll be more than happy to sort of like, walk you through the problem sheets. Okay. Right. So this is going to be the first part of the lecture because I need to break things up and make things a bit easier. You have the luxury of pausing the video if you don't understand something. So I do encourage you to do so. Okay. And just get ready for the second part. Okay.